Hey guys, welcome back. Today we are going to talk about surface area. We're going to start our introduction to surface area. And we are on page 42. Okay, the first thing that we need to talk about is the difference between two-dimensional and three-dimensional shapes. Okay, yesterday we talked about, or the other day, we talked about perimeter and area. Okay, this was of a two-dimensional shape. It was something that is flat, okay? You see these drawn, okay? When we get into surface area and volume, we're talking about three-dimensional shapes. So today we're going to title this Surface Area of Rectangular Prisms. Okay, and this is we are on page 42. Okay, write that down, and then I'm going to go over what all solids we actually cover in this unit. Okay, I'm going to draw them for you. So we are going to cover a rectangular prism, and then I'm going to give you an example of these things, okay, so you can know what I'm talking about. Okay, so it's a box. When I talk about surface area, I refer to a Kleenex box. Okay, let's think of a Kleenex box. Okay, all of the cardboard, the actual box, is the surface area. Okay, if you have a Kleenex box, all of the box itself, the cardboard, is the surface area. The volume is the Kleenex that are inside. Okay, the volume is how much Kleenex it will hold inside. So we talk about rectangular prisms. Next, we have triangular prisms. A triangular prism. You have triangles that are connected by the sides. Okay, in real life, you will very rarely ever see a triangular prism. Okay, you see them in science when they talk about the little prisms, the light prisms and things like that. But as an adult, I can't say that I've ever really seen a triangular prism a whole lot. But you do have to know the volume and the surface area of those. Okay, so for surface area, that's the outside again. Is the outside, and the volume is the inside. Okay. Then we have a cylinder. A cylinder is like a can. Okay, so I think of a can of Pringles. The can and lid are the surface area, and the actual Pringles are the volume. Okay. And then we talk about volume of cones and spheres, but we don't do cylinders of those, or surface area of those. So if we have a cone and then a ball, This is a sphere. Okay. So these are the different solids that we're going to be working with: a rectangular prism, a triangular prism, a cylinder, a cone, and a sphere. All right. So the other thing that you need to know about solids, okay, when you have a prism, it's named by its base. So this, I'm shading in big B. Okay, big B, this is area of the base. Okay, so how do I find area of a rectangle? Base times height. So big B is base times height of the shaded spots. Triangular prism, it's going to be named by the triangles, so they're our base. The area of a triangle is 1/2 base times height, right? So big B is 1/2 base times height. Big B, area of the base. For a cylinder, our bases are the circles. Okay, the circles. Do you see how all these sides connect the bases? Okay, that's really important for you to remember with what the bases are. So our area of a triangle is pi r squared. So our big B, the area of the base, these are our bases, is pi r squared. Okay, I'm going to give you a few minutes to write this down because it's super important for you to remember what these solids are. All right, then let's talk about surface area of rectangular prisms. Okay, surface area of rectangular prisms. Today we are going to start with lateral surface area. The lateral surface area. This is just an A, I don't know why. Okay. So, when I have the lateral surface area does not include the base, the bases. Okay? So, if I have a rectangular prism, these are our bases, right? The bases are the shape of it. Everything that connects, okay, all those sides that connect is the lateral surface area. Okay. We figure this out by the formula lateral surface area is equal to big P times H. Okay. Did you notice over here when we had big B, that was referring to the base. We found the area of the base. So P we know is perimeter, but if we have big P, what do you think we're finding the perimeter of? The whole thing? No, we're finding the perimeter of the base. So, why do I keep misspelling today? Perimeter of the base times h is still the height of the solid. Okay, this connects, it connects the bases. It's the thing that connects the bases. Okay, so your big P, you have your bases. These are our bases. Okay, so we're going to find big P is the perimeter of that base, and then the side that connects the bases is your height. So when I think of lateral surface area, okay, so when they say, they might give an example, I'm going to give you some examples of when you might find the lateral surface area. They might say if you are going to wrap the sides only of a box, okay? When they say sides only, the sides of it, they're talking about the lateral surface area. Most of the time they'll ask you for total, but sometimes they might ask you for a lateral, so you need to know this formula. All right, let's do an example. And I'm going to just draw it just a little bit of a different way. Let's say we have this box, okay? It's 1 feet by 8 feet by 6 feet. It's a huge box. It's like a refrigerator box or a deep freezer box or something. It's huge. Okay, our bases are the top and the bottom. Okay. So to figure out the perimeter, that's what we have to have. We're going to add all the sides of this bottom spot right here with the top spot right here. I didn't color that very well. Okay. So it has 4 sides. 1 plus 8 plus 1 plus 8 is equal to 18 feet. And then I have to know the height. The distance between these two, how tall it stands, is 6 feet. So my lateral surface area is perimeter of the base times the height. So 18 times 6. Which is 108. So my lateral surface area is 108 feet squared. And we're dealing with area, so it's still squared. Now let's do one more example of that. All right, let's say we have and this is my base. I'm just going to color one base because you know that they're parallel to each other. Okay, so this is 4 feet. And this is 4.5. And this is 2. Okay, remember that my formula is perimeter of the base times the height. So big P is 4 plus 4 plus 4.5 plus 4.5. Okay. So that's equal to 17. And then the height is how tall it is. It connects the two bases. It's 2. So my lateral surface area, 17 times 2 is 34. 34 feet squared. Okay. All right, that is the start of surface area and our introduction to solids. Tomorrow we're going to cover total surface area of a rectangular prism.